All right, so we're going to look at the sample answers to parts A and B, and then I'm going to talk through part C, because while we have the skills to do that question, putting some pieces together, that one was harder. Technically, we have the skills that we need to be able to do that, but it is a little bit more difficult. In the next chapter, we're going to learn the way they did it on these sample answers. We just haven't quite gotten all the way there yet, but I'll show you how you could do it with the skills that you currently have. All right? Part A. First part of part A. What's the probability that the person selected will be someone whose response is never and who is a woman? What do you think of their final answer? Yes. What do you think of the way they arrived there?
Yeah, should work.
Yes, ma'am.
Does it matter that they didn't make it a fraction?
Does it matter that they didn't make it a fraction? Good question. No, it does not matter that it's not written as a fraction. Yes, sir.
So do we gotta show like the work?
Well, you have to explain how you know.
So like how we show like the key.
Yeah, you would want to write your probability notation like this. If they had just had this right here, they would have gotten essentially correct on this part right here.
That's why you don't need the point 12 times.
They actually lost points for that.
So if we just put P, never woman, and then
So they lost points for this, not because it doesn't give this, and not because this isn't the right answer. But this information right here, the only time you're allowed to just take these probabilities, take that 0.12 and the 0.53 and multiply them together, is if these two things are independent. Do we know that at this point? No. Later on, they ask you whether or not they're independent, and then you could provide some justification. But at this point, they are assuming that these two things are independent, and we don't have any evidence to suggest that it is. So if they had left this part off right here, maybe even circled where they were getting it from on the table, so this is woman and never right here, it would be over 1, but since we've got a 1 right here, if my denominator was a 1, it's just going to simplify to this. That's why I didn't need to have it written as a fraction. If this was anything other than 1 over here, then yes, you would need to show that fraction or change it into its decimal form. So far, so good? Do you guys understand, before I move on, why they lost points right here? Okay. Second one, what is the probability that the person selected will be someone whose response is never or who is a woman? What do we think? Yes, this is absolutely correct. All of the people that answered never, that proportion was 0.12. That would be the total from the never column, together with the total from the woman row, minus the people that got double counted because they fit both categories. The only time that you wouldn't have a minus back here is if these things are mutually exclusive, and if that's the case and they give you a table, you're going to see a 0 in that spot. But yes, this one is correct. This part they received an essentially correct on. What is the probability that the person selected will be someone whose response is never, given that the person is a woman? Yes, sir.
so do we still have to show like the equation?
This part right here. Yes, you would want to show this. The only one that you wouldn't have to show work for is this one, and that's because the number is just straight plucked right from the table. Yes. This value right here is not to be found on the table, and so you would have to provide reasoning or justification for how you came up with that number. Here and then there. Yes, sir.
So if it's an or, then you subtract the total?
If it is an or, you want to take the total from this group plus the total from this group minus the ones that are in both groups. Because you would have counted them here and then you double counted them over here again. So this one plus this one, minus the both, minus the intersection. Yes. Did you have a question, Grace?
Yeah, and then do you want us to put it in percentages, or keep it like that?
This one said probability, so if you write it like this, or if you write it in fraction form, say 5864 over 1,000, because you didn't want to write it with decimals, or you write it as a percent, those are pretty much considered to be interchangeable representations.
Okay, so like if you put 58.64%, that would be okay?
That should be okay. Normally, probabilities, you're going to go after decimals. I will double check with the AP readers that I'm in touch with to find out if they're going to make that big of a fuss about a percent versus a decimal, as long as you have the right value and the right work. I would say to hedge your bets right now, I would leave it as a decimal. As far as I'm concerned, with all the training that I've received, fraction form, decimal form, percentage form, these are all appropriate ways of describing a probability. So, any other questions before we talk about the given that? Yes.
And also,
Yeah.
do we have to label, like, say, like, so like 0.5864 of like getting somebody, or getting a woman or somebody that doesn't take their meds?
This notation right here made sure that they took care of that information, so you can either write it out in sentence form, like with multiple words, or you could have this notation here. Those would be interchangeable ways of showing that you understand what this value right here is telling you. You're welcome. All right. Any other questions on this part? You guys have got great questions here. Any other questions on this part? Okay. Once we have a given, that is now conditional. We're going to have a line in our probability notation. Whatever the total for this is needs to be our denominator now, not the grand total. Once we have something that is known or given, that's our denominator. That's where that 0.53 came from right here. The numerator is the intersection of these two things. So the numerator came from this right here. Again, not the way they came up with it, but just grabbing it straight from the table. If I want to know, never, given that they are a woman, once they tell me the given that, what I would be looking at on the table here, let me see if I can pull up my little annotate thing. I'm only looking at that piece. As far as I'm concerned, all the rest of the table can go away once I have given information. This is my whole world with given information. Given that, that's the only thing I'm looking at. And so everything would have to come out of this row. So then I'm looking for woman and never. There's my numerator. Out of all the women, 0.53. So far, so good? Okay. So that's where they got that 0.12 from. In part B, they went ahead and they were able to answer the question that they were relying on to answer the first part. They showed that these two things were independent. How did they know? How did they know that these two things had to be independent? Going back to look at the table, what's just the probability that somebody answered never? 0.12 out of 1, so just 0.12. In part C, they asked you to calculate the probability of never with this information that you know they're a woman, and it came out to also be 0.12. If the probability does not change with new information, with new given information, then that new information had no effect on it at all. Your chances stayed exactly the same. If you know they're a woman, it's 0.12. If you know they're not a woman, it's 0.12. If you know nothing about them, it's 0.12. The probability stayed the same, even though we had information about their gender. If we get information about their gender and that changes the chance of a never answer, Now it's not independent. You would say these are dependent things. Does that make sense? So they got an essentially correct down here. They got essentially correct on these two. They got a partially correct here, which means the whole thing was graded as partially correct. Did you have a question, Max? Okay. Let's compare that to this one. I don't think we'll look at all three because I do want to show you how to do that last question. So here they wrote it out a little bit better. Probability of never and woman, 0.0636. The probability that someone whose answer is never and is a woman is 0.0636. So one of the things that they put into the notes is that this piece showed understanding. It was not a required component of the question, but it did show understanding. If you're going to add something to it beyond just what the question is asking for or what we've practiced you need to do on that, just make sure that it's correct. As we saw on the previous person's question, they didn't need to show that multiplication, and unfortunately that's what knocked them down because that showed an incomplete understanding of that concept. I personally like it like this right here before I pop those numbers in so that I can make sure to get the right numbers. I didn't even touch anything that time. This was not required for full points on this part, but this is where those individual numbers came from. Probability that you pick someone who said never or is a woman is 0.5864. And then I really like this right here. Your numerator is always going to be these two with the and, where they intersect. The denominator will always be the bottom part. So I almost see it like I take this and I flip it into a fraction this way so that I know this is my denominator. Yes, they are independent since the probability of someone saying never, given that they are a woman, and the probability of someone saying never should be the same in order for the two events to be independent. In this case, both probabilities are equal to 0.12, hence the events of saying never and being a woman are independent. Is that sufficient? Yep. Yes, ma'am.
So we could just put like the probability of never and then never given that it's a woman
And show that they're equal. Yes.
so that would be okay.
Yes. Now, one of the things that I do want to say, oh, there we go. My apologies. On the other person, I said they were right, and they are correct in their work. However, did they actually answer the question? No. If they had just added one little sentence that said, yes, they're independent, along with their work, they would have gotten full points here. My apologies. I was excited and wanted to move on to the next person. So showing the work is important because now you have that justification, but then you do actually have to answer. If it's a yes-no question, you need to have a yes or a no as part of it, or it will immediately knock you down. Right. With our last little bit of time, I want to show how to answer that third part. So in order for me to do that, I actually have to scoot this over here. Give me just a second. And I'll show you how we could go about doing that with the skills that we currently have. Like I said, next chapter, you're going to learn a shortcut way of doing this. The only one that we have really practiced here is the at least one. All right. So I'm going to get rid of their work so that I can have room for mine. How many people are we talking about? 5 people. So if I want to know the probability that at least 4 of the people will always take their medicine as prescribed, I would need the probability that all 5 take their meds as prescribed, plus the probability that only 4 take their meds as prescribed. Yes, sir. Yes, you may. This top one is much easier to calculate the probability of. The probability that all 5 people take their medication as prescribed. What's the chance that you take your medication the way you're supposed to? 0.54. Now, this one kind of goes without saying, but if I'm at my house and I take my medicine as prescribed every day, and you're at your house, I have no idea where you live, does whether or not I take my meds have any impact over whether or not you take your meds? So these are independent events, which means I would multiply those probabilities together. So it's 0.54 for each person, or 0.54 to the 5th power. I am actually going to go ahead and write this out because it will help me understand the next one. The probability that I need to add that to is the probability that only 4 people take it the way they're supposed to. Not all 5. So I've got to consider each individual person here. How many people are we talking about? 5 people total. What's the chance that you don't take your meds as prescribed? 0.46. Okay, so if the first person does not take their medicine as prescribed, but everyone else does, that's one possible thing that could happen that has only 4 people taking it correctly. I'm assuming that each of these people have names though, right? So what if the first person, I'm going to call him Joe, what if the first person really did take their medicine as prescribed? What's another way that only 4 people take it the way they're supposed to? Yeah. Maybe the second person didn't take it the way they were supposed to. Sure, thank you. First person takes it correctly, second person takes it correctly. What's another way that exactly 4 people take their meds the way they're supposed to? Third person didn't take it the way they were supposed to. Are we starting to notice a pattern here? What's another way that I could write this so that exactly 4 people take their meds properly? Fourth person didn't take their meds the way they were supposed to. So the first 3 do. And the fourth one is the one that ruins it all. Are there any other possible arrangements that have exactly 4 people taking their meds the way they're supposed to? If the 5th person doesn't. I need to add all of these up. And then add it to 0.54 to the 5th power from up here. Next chapter, I will show you a much, much faster way of arriving at the same correct answer. You should come out with a total probability when rounded of 0.241. Okay, that's what we worked on earlier. It's equal to the probability of at least 4 people take their meds correctly. Because of this pattern, notice each one of these has 4 people doing it right and one person doing it wrong. And then there are 1, 2, 3, 4, 5 variations because we have 5 people. We're going to have a formulaic approach to this in the next unit. Do you guys have any other questions for me? So things that I definitely need to see: probability notations of some type so that you're describing what you're finding. When things are independent is when you can multiply those whole probabilities together. Tree diagrams can be really helpful sometimes. If they give you a table and you feel like a Venn diagram would be more helpful, you're welcome to sketch one of those out. The results of the vote. It wasn't as far apart as I thought it would be, but the desire of the class is to push the test to Monday. So we're going to review in class tomorrow. I'll take any questions you guys have, and then we will have another full day to review on Friday. We will take your test on Monday. Tuesday is a Zoom day. We have an altered schedule. I'll talk to you next week about what it looks like on Tuesday. We're going to Zoom together for 20 minutes. I'll probably use that as Q&A time.